Hello everyone. Today we'll be solving the problem number 90 subsets 2. We have already solved subsets 1, right? So we'll be solving subsets 2. So what the question states here, we are given an integer array, this one, nums, right? So just give me a second, 1 second. Yeah, we are given an integer array nums that may have duplicates as well. So see here, 1, 2, 2. We already have the duplicates within the nums, the first example, right? So we are given an integer array nums that may have duplicates. We need to return all the unique subsets, nothing but the power set, right? So the output must not have duplicate subsets, but the order of subsets doesn't matter, right? So the output must not have the duplicate subsets, but the order of the subsets doesn't matter, right? So we can use backtracking to explore all the subset possibilities and skip the duplicates, right? So we can use backtracking to explore all the this one subset possibilities and skip the duplicates, right? So this is what they have given. Uh, uh, One thing, the output must not have duplicate subsets, but the order of the subsets doesn't matter. They've strictly mentioned, right? So we need to return all the unique subsets. That's what they have mentioned as well, right? And I have said that we can make use of the backtracking just to explore all the subset possibilities and skip the duplicates. Means we will be going with the backtracking mainly, right? So let me write it. So yeah, this is fine, right? So we are done with the this one question part, and they have given us wonderful examples just for the sake of understanding right here. So for the input 1 to 2, we have to get the output this one, uh, empty subset we have to consider for everything, right? So empty array is also empty subset is always a subset of this one, the array elements, this one whatever we have given, right? So this is one thing that we need to keep in mind every time. So this one, we have 1 2 1 double 2 as well, 2 double 2. So they have mentioned that we need to return all the unique subsets, nothing but the power set basically, right? So here same goes with 0, empty and the 0, as we have only one element 0, empty subset as well as this one 0 we need to consider, right? So this is fine man. And again we'll be going with the backtracking, right? So let me consider the first example. Second example we have only one element, so let me consider first example for the approach. So example we have here, nums equals 1 2 3, right? So again we already have that one. This is fine, 1 2 3. So first what we will do, we will sort. So we'll be going with the sorting. Why? Because sorting makes the duplicate handling easier. So when we sort this one basically, so sorry, we have 1 double 2, not 1 2 3, right? So sorry, I got confused here, 1 double 2, right? So when we sort here, in this case it is already sorted, so we don't have to worry, we get 1 2 2 itself, right? So let me write it here, 1 2 2. So let's start with a empty subset first. We'll be going with the empty subset. Then at index 0, we will pick 1. So we have the 1 at index 0. We have 2 at index 1. And we have 3 at this one, 2 at index 3 as well. Sorry. At index 0, we will pick 1. Nothing but now we have 1. First we pick the empty subset. Then we have 1. Right. So then we will explore further. At index 1, we have 2. So next we will be going with a 1 comma 2, right? Simple. And then next we will pick 2 at the index 3. So this will lead to next 1, sorry, 1 2 2. We have the value 2 at the index 3, right? So sorry, index 2, right? Why this one I have considered here? So we are going with a 0 1 2. So indexing itself I wrote here. So this is fine man, 0 1 2, sorry. At the index 2 we have 2, we will pick the value 2, so this will be 1 2 2. So then after this one we will backtrack each step, right? So when we skip the duplicates, means if the same number as previous at the same recursion depth, we will avoid the repeats like 1 2. See here, again we will be considering, when we consider 1 2, again we will get 1 2 basically, that is repeated, right? So uh, we will stop that one being generated twice basically, in simple terms, right? So now we will continue until all the paths are explored. When we continue, so individual number 2 we will get basically, right? So individual 2 we will get, so 2 1, we already have 1 2, so we'll not consider 2 1. So like that itself we will be backtracking basically, right? So again, we can consider one more this thing after 2 is 2 comma 2, right? So this we have, these are different numbers, right? So this we are not repeating this one basically, these are different numbers, unique numbers basically in the array, right? So 2 and 2. So this one also we can consider. So what is the output that we got here? Empty subset 1, this one 1 2, and this one 1 2 2, 2 and 2 2, right? So this is equivalent to the output that they have mentioned for the example 1 within the question, right? Same output, this one 1 1 2 1 double 2 2 2 2, right? So our approach works absolutely correct. Once the backtracking or the recursive backtracking or the recursion here works absolutely correct, right? So basically backtracking is nothing but the recursion, man, pure recursion, right? So this is fine. So now we got the output equivalent to the output that they have mentioned for the example 1. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big of 2 to the power of n. Why it is big of 2 to the power of n? Because we explore all the subsets. Nothing but here big of 2 to the power of n possibilities, right? So, or 2 to the power of n possibilities in simple terms, sorry. And uh, we also handle duplicates by skipping, right? So we will be handling duplicates by skipping, that I showed you in the approach itself, right? So we will backtrack when we get 1 2 simple, and when we get 2 1, so we will not be considering 2 1. The first one whatever we get here, this one we will consider 1 2, right? So this is what now we explore all the subsets, nothing but 2 to the power of n possibilities, and handle the duplicates by skipping. So overall time complexity would lead to big of 2 to the power of n. This one. Overall time complexity is nothing but 2 to the power of n. So what would be the space complexity here? The space complexity would be big of n. So the space complexity would be big of n, because the recursion depth and the temporary list at most store n elements. Just remember this. We know that the recursion depth, the worst case, right? Recursion depth can go up to big of n. We have already solved trees, many things. Most of the times, the tree problems are solvable. This one can we solve that one using the recursion itself. And there also, I said you multiple times, the recursion depth in the worst case can go up to big of n, right? So here recursion depth can go up to big of n, and the temporary list also will be considering here, that can store at most this one n elements, right? N elements. So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of 2 to the power of n and big of n respectively, right? So let me delete this one. Now as we are completely familiar with the approach and the this one complexities part, we are good to write the code. Let's start writing the code. First thing here would be let's go with the result list. So we have to store all the unique subsets, right? So somewhere we have to store. For that one, let's make use of the result list. So I'll just go with the list here. List. Again, let me go with integer. So this is fine. Let me consider the variable res here. I'll just go with array list. So this is fine. Next line would be uh, we have to sort just to handle the duplicates easily. That's what we did in the approach as well. First step itself, I showed you sorting, right? So in our case, we considered this example, this was already sorted, so I just wrote this one directly, right? So we have been given two examples, but in our case both of here, this one also, if I sort, we get the same this one value. Here also it is already sorted 1 2 2, right? So I'll just go with array dot sort. We have to consider all the edge cases, right? So we have to sort. So I'll just go with the integer. uh, so array dot sort. So yeah, sorry, I have to pass the nums, man. I'm thinking of something. So this is fine. Now let's start backtracking from index 0. We'll be starting from the index 0 with an empty current list, right? So for backtracking, so I'll just consider the helper method backtrack, right? So I don't want to write within the main method itself, nothing but subsets with the duplicates, right? This one I'm saying, telling main method. So let's go with the this one. What do we call? Helper method backtrack. So I'll just go with private void. So this one will be backtrack. So the parameters I want to consider here is nums basically array. I have considered array, right? So this is fine. Then start also we want. Then we need current. So I'll just go with integer current. I'll just consider CURR here, and also we need the result variable. So this one, same thing, list. Within the list, this will be integer one. So this is fine, and the variable name result. So this is fine. Now within the backtrack method, helper method, so let's add the current subset, nothing but copy of it basically to the result. So I'll just go with result dot add new array list. This is fine. Let me pass the current. So this is fine now. Now let's do one thing. Let's loop through the remaining elements starting from the start. So I'll just go with the for loop here, and I equals start. This is fine. I less than nums dot length. This is also fine. Let me I plus plus. This is fine. Yeah. Mm, Within the for loop, we are just looping through the remaining elements, that is starting from the start. So first step itself within the for loop, we have to skip the duplicate numbers, right? So means here in simple terms, we are skipping the duplicate numbers, or we have to skip the duplicate numbers at the same recursion depth. So I can just write it in this way. I hope this works. Let's see if I get the error. Let me change this one. If I is greater than start and iterated value of the nums, this one, this is equal to the previous number, nothing but the nums of I minus 1. uh, in that case we have to skip in the sense I'll just make use of the continue keyword in the Java. So this is fine. I hope this works. Let's see. Let's choose the current number first. So this one will be current dot add pure backtrackman. So this one will be iterated value of the nums. Next, let's explore further with the chosen number. Means let's recurse, right? So I'll just copy this one. Let me paste it over here. So this one will be nums, comma I plus 1. This is also fine. Let me go with current. Let me go with the result as well. So this is also fine. The final step here would be backtrack. Means we have to remove the last chosen number accordingly with the approach that we discussed, right? So this one for removing, I'll just go with the remove, right? So this one has to be current dot size minus 1. Simple. So we are done with the backtracking, pure backtracking, right? So this is fine. Let's make use of the helper method backtrack within the main function or the main method subset with a dup, whatever they have given here, subsets with dup, this one, main method. So I'll just paste the backtrack here, nothing but what are the this thing what we need to do here. So basically we have to start the backtracking from the index 0, as we had discussed in the approach. So we have to start the backtracking from the index 0 with an empty current list. With the empty current list means we have to go with the instance of the array list, right? So I'll just go with nums here. From 0 we'll be going with, so this one, nums 0, and also array list. So this is also fine. Mm, Also we need the result variable, right? Yep. We have to return the result itself next. So finally we have to return the final list of unique subsets. Means I'll just give here return result. Fantastic. We are done with the code, right? So let me format the code once and let me hit the run button, man. So let's wait for some time. Let's see whether this works or not. Yeah, hopefully. So this was I was worried about this one, not this one basically. Uh, basically this one, line number 12. This is fine. Now the sample test cases are getting passed. Let's see whether this works for all the test cases or not. Hope this works for all the test cases. Sorry. Yeah, this works for all the test cases, right? So we are done with the coding part, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.